All right, good afternoon, everybody. And welcome to Seminar 8, and it is about PCA Factor Analysis. Now, I want to remind you of something that we did during Seminar 4, was about Cronbach's alpha. Can you just write in the chat room why we use, or what's the purpose for us to use Cronbach's alpha test, please? Can you just write in the chat room, why do we use Cronbach's alpha? It's in session 4. Why do we use Cronbach's alpha? Nobody knows? I'm pretty sure somebody would know. Joy, why do we use Cronbach's alpha? Yes, thank you, Sayara. It is about reliability. We use Cronbach's alpha because we want to test the reliability. Now, reliability of what? Of what exactly? Remember, at the time, I gave you a good example. About, for example, that example was about testing or seeing the level of satisfaction of Murdoch University students with Murdoch University services. And we mentioned in that example that you cannot go outside to the students and ask them one question. Saying that, okay, I don't want to. I want you, what's your level of satisfaction as one question, and that's it. No, you need to set up a set of questions, maybe 10, 20, 30, I don't know, and then you go and ask them all together. And at that time, we mentioned that those 30, we want to check whether they are reliable to be together as one scale, and that's why we tested reliability, so that they are considered as a scale measuring satisfaction with Murdoch University students. Now, today's topic is a bit similar to reliability in terms of measuring scales, but in fact, today's topic, the aim of it is factor analysis. In fact, in general, the aim is to bring in those 30 questions and reduce their number, and create new variables that are relevant to those 30, 40, 20 questions with limited numbers and new variables. Those new variables are going to be much more condensed in terms of information and in terms of data or knowledge, I would say, that they are going to convey, and they are simple in numbers. So dealing with a small number of variables is better than dealing with a greater number of variables. So that's the aim thing about PCA factor analysis. Reduce the numbers of variables in scale and factor them or group them into condensed variables. Now, that's the case in general. Let us, this is just as introduction. Let me see here what we have. Okay, we mentioned that. So the aim, remember in this unit, we always have 4 questions to answer. What statistical technique we have to use to solve a specific problem, how to use it, how to interpret the results, and how to report the results. So for us, when we want to go for factor analysis, we mainly aim to simplify its simplification and reducing the number. If we have 30 variables, we can reduce them to 5 or 6 or 2 or 3 even. So reducing the number of variables and making them more condensed. So if we want to reduce the number of variables and making them more condensed, hanging together, all right, this is why we use PCA factor analysis. Here we have an example. Say, for example, if we have a Likert scale questions in a questionnaire, and we are asking people about their satisfaction with the hotel, one of the hotels. So here is relevant to stuff. Stuff are, they are friendly, you agree, disagree, strongly disagree, whatever it is. It's just 5 like scale questions. And the stuff are courteous, competent, etc. And then room size is nice, room size is good, blah, blah, blah. We have 4, 5, 6, 5 answers. Good, bad, very bad, whatever it is. And then bid size, view, cost, etc. Then we go for the catering. Then we have extensive menu choice, service and attention, cleanliness. You notice that all those groups, I mean, we have 3 groups. If we put them for Chromebacks Alpha, we are going to have a test for all of them as reliability scale to test the satisfaction, right? So we know it. This is a satisfaction. We put it on Chromebacks Alpha, and it's going to tell us. But for factor analysis, in fact, it's going to group those variables according to what they mean exactly. So here they are related to staff. This means that they are going to be in one group under the title hotel employee staff. Definitely, SPSS is not going to give you the title. It's you who are going to decide the title. But SPSS is going to tell you that those 3 are going to be together. Go and find a title for them. All right. Now, and those, for example, they are going to be together under one title, under one variable. And then those together are going to be under one variable. In this regard, we have reduced 10 variables to be into 3. More condensed, more simple, but more efficient as well, because we are dealing with more structure, I mean, condensed information of the and variables. They are solid. They give you, in this one variable alone, it's going to represent those 3. So this means that this is a really strong variable. It is representable. It does give us good, data for analysis. All right. So in this regard, we understand now that factor analysis is going to make sure that, in general, factor analysis is going to make sure that those variables that belongs to this group, for example, they are all related to each other. So they do not relate to those variables or those variables. This means that each one of the group is a group in itself. There's no overlapping between them. Second, once SPSS decides this, it's going to make sure that this group is going to be converted into and calculated to be one variable. So it's going to be a new variable to be calculated for this group, and a new variable is going to be calculated for this group, and a new variable is going to be calculated for this group. Without deleting those, by the way, without deleting those. So in general, this is SPSS. I mean, this is PCA factor analysis, simplifying, condensing, reducing the number of variables, but having more strong and representative variables. Now, so those are, I mean, those variables, the new variables, they are called factors, and that's why we call it factor analysis. So factors are the underlying dimensions or constructs to which highly intercorrelated variables are subordinated. So we have a group of variables, they are highly interrelated or correlated, so that's why we decide that they belong to this group, all right? And so, for example, the superordinate of factor of room equality on the previous slide contains variables like cost, room size, bed size. So when you read cost, room size, bed size, this is relevant to the room. So if we calculate them using SPSS, SPSS is going to discriminate those variables and put them together, saying that, okay, you belong to one group. Now, SPSS, as I told you, is not going to tell you what's the title. You have to go and read those variables, and then you decide what's the title, because you know the data. All right? And also factors, because we call it factor analysis, those new variables that are resulted from the interrelated variables together, they are called factors or dimensions or constructs. So factors, dimensions, or constructs. Now, sorry. Okay, theoretical introduction. Let us just consider the following, please. And when we do factor analysis, theoretically speaking, if we are researchers, we want either to prove that one theory is valid or not, or we want to create a new theory, simply speaking. Now, suppose that somebody in India, they have already collected data and they tested PCA factor analysis and they got good results in India. Now, for us here in Australia, I'm with you, you are my team, and we go together, we collected data similar to the Indian data, but it is Australian data, and we want to run the PCA factor analysis. We are going now with our data from Australia, going to confirm whether the Indian results were valid to be applied in Australia or not. So that's called confirmatory factor analysis. Now, remember that Indians, when they started their own data, in our example, they started it without having somebody before them doing that data. So for them, they were explaining and exploring, in fact. So if you don't have any precedents, so you are exploring or explaining. If you have precedents, you are confirming whether precedents are valid to be applied in your context or not. All right, let us have, now this is PCA factor analysis. In fact, some of the statisticians, they do not consider principal component analysis as factor analysis. To be honest, it should be as factor analysis. And as you will see, and I will show you now that SPSS has two many different types of factor analysis, but principal component is part of it, and it is one of the nicest as well. It is heavily used as well. Now, PCA is a statistical approach that derives a linear combination of variables like regression, such that maximum variance is extracted from the variables to identify the mean factor. I understand that this is not really easy for any of you. Now, let me explain it easy like this. In week 5, we studied correlation, and it was just one formula to calculate the relationship, magnitude and significance of the relationship between two variables. Simple and straightforward. Now, in the week after, we studied regression, and I told you at the time that regression had part of regression is correlation. So regression has correlation as part of it, but it is not everything. It has also ANOVA, because you see the ANOVA table in regression. This means that regression has ANOVA as well. So regression includes correlation, multiple correlation, and ANOVA. And that's why it has different anti-tests as well, by the way, from the coefficients table. Now, it has different types, three types of statistics under regression, techniques under regression. Now, for PCA factor analysis, it has regression in it. Now, if it has regression in it, then it's going to discover the relationship between the variables. So it's going to group, first of all, ANOVA is going to group the variables. Then regression is going to investigate whether those variables are related to each other as a group. And then it's going to differentiate between those groups. So we got those variables. We separate them according to groups. And then we make sure that they belong to the groups. And then we make sure that each group differs from the other group. You got my point? So that is exactly what's meant by the first paragraph. So don't bother yourself with this terminology. Separating variables into groups, make sure that variables in each group belong to that group or related to each other, then make sure that each group differs from the other group. Simply speaking, that is factor analysis, or simple principal component analysis. Now, once we have, sometimes in fact most of the times, once we have 3 different groups, for example, or 4 different groups of factors or variables, now we see that some of the variables in each group may overlap with other groups. may be related to other groups as well. So what we do now, factor analysis is going to make discrimination. It's going to ask that variable, stop and shut, which group you're going to go for. I'm not going to wait for you to be in those two different groups. You have to be in one of them. Simply speaking, that's just like part of a movie. And it's not reality. In fact, in reality, SPSS is going to calculate that something called discrimination. So it's going to discriminate or rotation. Factor analysis is going to rotate those variables and see where they can best fit in which group, and then there's going to prevent them from being in two groups. All right. So this is factor analysis in general. I know that I have spoken theory. It's better that we jump into practice. But before we proceed, we need for the assumptions. Now, large enough sample. So there should be something called sample adequacy, and this is an assumption that is going to be tested after we got the results of the PCA factor analysis. We are going to have one of the tables that tells us that this assumption has been violated or not. In general, the assumption says that for each variable included in the analysis, you need to have at least five cases. So suppose that I collected data from my students, and my students, they are 100 students, and I have 10 variables. Can I say that I have met this assumption? Yes, if I have 5 variables, I need to have 50 cases. If I have 10, for example. If I have 10 variables, then I need to have 10 by 10, it's going to be 100. So, okay, that's going to be it. Now, statistical interference is improved if the variables are at least approximately normal. In fact, we are dealing most of the times with ordinal data, and we're not going to test normality for this case. Now, linear relationship among all the pairs of the variables, this is going to be tested after the test. We will have part of the outputs going to be investigated by this. So I think this one and this one, they are going to be tested after we run the test. Now, outliers, we know it, and interval data, that's the PCA factor analysis is always with interval data. Now let us proceed to see here. PCA tells us how many underlying dimensions. I'm not gonna talk about this slide now. Let us go for the practice, and then you will understand what does it mean exactly. So not to waste our time with theory. Now we have this. I want you to go to chapter 18A on your LMS. Please download it and give me thumbs that you are done, please. Give me thumbs when you are done, please. Chapter 18A. Thank you. All right. What about the others? Good. I have 6 have not responded to me yet. Good. 5. And myself 4 now. Anyway, now I'm gonna share my screen so that we work together and we follow up. So let me just share my screen now. All right, here is my screen. I think you can see it. Now, factor analysis is we go for analyze. I'm going to be going slowly so that you can follow me. It's analyze, and then we go for dimension reduction. This one, dimension reduction, and then we go for factor. Analyze, dimension reduction, and then factor. We take it. All right, we have this window. Now, in the slides, on the slides it says that we need to select variables Q, question 13, 14, 34, 35, 36, 39 to 38. So they are all together considered to be as variables that should be included as in our factor analysis. Now, my advice to you, because on the slides it says question 3, 14, so we have those numbers are here at the end, but it's easier that you right-click here, right-click, and then select variables by names. You have those names. So we are talking about question 13. We start moving them. This is question 13 and 14. Then we have 34, 35, 36. 34, 30, no, this is 33. We have 34, 35, and then 36. And then we go for 39 to 48. It's 39 until 48. Move it. All right, now we go for descriptives. Now wait a while here. We go for descriptives. We make sure that coefficients is selected and KMO and Bartlett's test as well. We make sure that initial solutions here in statistics is selected. So we are okay now. We click continue. Now on extraction button, click on it. We want to have screen plot. Make sure that principal component is selected. By the way, I told you that we have different types of factor analysis. Here they are. How many of them? 1, 2, 3, 4, 5, 6, 7. So we are using the principal components. Okay, we want to have screen plot. Now, eigenvalue, keep it in mind because in the results we are going to talk about it. So eigenvalue here is something that, based on which we are going to decide how many factors are going to be included in our analysis. So in this regard, we are telling SPSS, do not include factors that have eigenvalue that is less than 1. And we're going to explain that more once we got the results. Click continue. On rotation, we are going to select Varimax. All right. All right. We click on Varimax. We go for options. We want to have exclude cases pairwise and the coefficients. We can say that sorted by size, and we click on this suppress, and we change this to be 0.3 rather than 0.1. Also, we'll have a story that I'm going to tell you once we got the results. So far we are okay. We click continue. and then we are ready to go. I want to have a question for you. Okay, we're going to repeat this again, but I want to run so that we save it. It's analyze, dimension reduction, factor. We move all those questions that are on the slides, move them to the right. 13, 14, is it 14? 13 included or not? Let me make sure. Is 13 included or not? Yes, 13, 14, and then 34, 35, 36, and then 40, 39, 48. All of them. When we go for descriptives, we make sure that initial solution is selected, coefficients and KMO balance. Then we click continue, we click extractions. We make sure that principal components is selected. Eigenvalue is number one. Eigenvalue is important to us because we are instructing SPSS now, do not consider any factor that is this with eigenvalue less than 1. I want script plot, and I'm going to explain what does a script plot, how we interpret it once we got the results. And then we click continue. Go for rotation. We have Vilemax, a rotated solution. We click continue. We go for options. We select exclude cases pairwise, and then coefficient display format, sorted by size, and then suppress small coefficients by 3. And this has a nice story, the 3.3. I'm going to tell it to you once we finish. Then we click continue, then we click OK. Here are the results. My question to you is on the poll now. Do you have those results? Do you have results? Answer this poll, please. Kizank, what about you? Lucky Dima, Malkit, Mandy. We have 2 names. Mandeep Kaur. Malkit, you don't have them? Malkit, I repeated that first time and second time. Are you facing a problem following us? So what's the problem with you, please? Ah, yeah, I see. Your laptop is slow. All right. Okay, I'm going to repeat it again. Analyze, dimension reduction. Where is dimension? Dimension reduction, and then factor. We move all those variables. They were here. We moved them because they are on the slides. So we have to move those guys from here to here. There are questions 13, 14, 34, 35, 36, and from 39 to 48. We click descriptives. We make sure that initial solution is selected. Coefficients, KMO, and balance. We click continue. For rotation, we make sure that Varimax is selected and rotated solution is selected. Under the display, we click continue. Under the options, we have exclude cases pairwise. And then under the coefficient display format, we have sorted by size and suppress small coefficients. Should be, we add here manually, we add 0.3. We click continue and we click OK. And there we go. Here are our results. Again. Now, the first thing is that you have to stable, you have other things. What I want you to do is, let me go back to my slides, but now I want to make sure that you've got those results, everything is all right. I'm going to go back to my slides. All right, so here is this table, correlation table. Here is the correlation table. In this correlation, you are gonna scan, see whether you have relationships that are less than 0.3. So we want to have them, most of them, as greater than 0.3. In fact, I highlighted for you two variables where they are having negative correlation and they are less than 0.3. But this table is just an indicator. It's not something that you need to stop the test for, because we have KMO and Balance tests that tell us whether the correlation is enough or not. I mean, this amount of correlation is enough or not for us. Now we continue to proceed. Here is the tests of assumptions. So we have two assumptions: adequate sample and correlation. So if we have adequate sample, means do we have number of cases that are adequate for the number of variables If your results do not match, this means you made a mistake. You have to repeat and don't make a mistake. So what I advise you to do now, what I advise you to do is, I want you to follow up with us, and then you practice this alone until you get the results, because this session has been recorded, so you will get the recording. So don't waste time now, and also I'm not also going to waste more time repeating and repeating. So we're going to do it alone. Once we finish, I'm going to follow the recording until you get those matching. Yeah. All right, Nafji, I rely on you. And then for this KMO measures, now KMO measures sampling adequacy. We said that at the beginning. We said that one of the assumptions is that we have 5 to 10 variables per 5 to 10 cases per variable. So we have included 15 variables. This means that we need to have at least 25 cases in our data. In fact, we don't need to count, because this KMO is going to tell us if this result is greater than 50, not 5, 50. Be careful, this is 50, not 5. So KMO is greater than 50%, and this means that sampling adequacy. Okay? If also, and if this is significant, I mean less than 5%, this means that Bartlett's test is significant, and this indicates that there we have no problem with correlations. We have no problem with correlations. Now we do not proceed if any of them has a problem. In all cases, now both of them are met. Now we move to next to see interpretation. Now here, this is called the communalities. Now, communalities, the table tells us how much each variable is correlated with the factor. Now, so we have common factor. We have common factor or common factors. So that variable, how much it is correlated with the factor. The factor is a group of variables, all right? The factor is a group of variables. So if you have a look, for example, the first variable, this one, is correlated with the group of factors with 0.75, which is really great. Now look at the second one is correlated with 0.67. So we have a look. We hope that all of those values range between 0.3 to what is it's greater than 0.3. It's greater than 0.3. So here the range is between 0.3 and 0.767. Right? So it is 0.353 and 0.67. Here is the range between those and those. Now this is the communality. So we understand from the communalities that how much this one is interrelated or correlated with the common factor in general. Now this is how we understand this communalities. Now this table is a table of your life. This is where we interpret everything. So what we are going to do is, first of all, remember the eigenvalue I told you. Eigenvalue is that we instructed SPSS not to consider any factor that has eigenvalue less than 1. So look at this here, the border here. So after this is empty. This means that all those eigenvalues, here is eigenvalue, you can see. So they are all greater than 1. So if we select eigenvalue of 9.9, then this one is going to be included. But we don't want it because the threshold and the generally accepted threshold for the eigenvalue is 1. So that's why we have now 3 factors from here. 3 factors included with eigenvalues of 1.186, 1.879, and 5.717. All right? Now, let me explain to you what do we mean exactly by the eigenvalue. Now, here is 5.717. This is 5.717, the eigenvalue. What does this mean? How many variables do we have in our analysis? How many variables did we include in our analysis? You remember? 15. Now, this means that 5.717, this factor number one, is equivalent to 5.717 variables of the 15 variables included in the analysis. So one factor alone is equivalent to explaining variance that can be explained by 5.717 of the 15 variables included in the analysis. Remember, let me just make it easier. How many variables we included in the analysis? We included 15, and we wanted to group them. So we have one of them as a group is this factor number 1, and it has an eigenvalue of 5.717. Now, if we say this means that this factor alone can explain what 5.717 of the variables of the 15 variables, what 5.717 of the 15 variables can explain. Now, let me just give it to you from another point of view. If we say that we have 15 variables, so 100% is 15 variables. So how much percent is 5.717 of the variables? Now, let me just explain from this point of view. Now, if we have 100%, 16 variables, so how much percent for each variable? It is 6.66. How do you do that? You just divide 100 by 15. If you divide 100 by 15, then each one would be 6.66. All right. Now, we have this variable alone, this factor alone is 5.717, right? This factor alone can explain what 5.717 variables can explain. So multiply this 5 by 6.66, you will get 38.11% of the variance of the total 15 variables. Now, here is eigenvalue is 55.717 and the variance is 38.111. This is the one. I hope now you understand now the eigenvalue, what does it mean, and variance, eigenvalue of variance, what does it mean? Variance percentage is how much this factor can explain of the total variables. And eigenvalue, how many variables are included in this of the total variables. I think that this is now clear. Let us move to the second variable. Second variable has eigenvalue of 1.879. If you multiply it by 6.66, I want you to do it, use your calculator. Use your calculator, please, and tell me what's the result of 1.879 by 6.66. Go for it, please. All right, it is 12.53. You can see it, it's here. All right, thank you. 12.53. 12.53. Yes, you can see it, it is here. It's here. So, simply speaking, eigenvalue is how many variables are included in that factor. How many, what is equivalent to how many variables are included in that factor multiplied by, out of the total. And this one is 100% is what is the percentage for each variable to be multiplied by the eigenvalue is going to give us this 38.1. So for this one, 1.879, if we multiply it by 6.66 is going to be 12.53. Now, if we go for the last factor, the eigenvalue is 1.186, and if we multiply it by 6.666, it's going to be 7.906. Now, let's have a look here. We know that because this one has a greater eigenvalue, the first one, so it has 38% of it can explain 38.11% of the total variance of the 15 variables at all in general. Now, if we go for the second one, it has 12. But if you add 12 to 38, what do we have? 50. Now the third one has 7. If you add 50, it's going to be 7.9, it's going to be 58. Now this tells us something important, that those three factors together can explain 58.547 of cumulative. Yes. So they are all together can explain 58.547 of the 15 variables. So look, from the very beginning, we said that we conduct factor analysis in order to reduce the number of variables and make the information condensed. So I can now remove the 15 variables, not to use them in my analysis. I can use only 3 variables, which are the 3 factors, and they can give me 58.5% of what would all the 15 would give me. You understand now what I mean by factor analysis? Of course, that would be great if it is more than 58.5. Of course, the larger the cumulative, the better. Yeah, the larger the better. Yeah. So do you know now what I mean by factor analysis is condensing, reducing, and make it more efficient data. All right. Now, do you know eigenvalue? What does it mean? Eigenvalue? Yeah, this one, the 5, this is called eigenvalue. If we clear it, this is called eigenvalue. Eigenvalue. And you know now what does this 5 eigenvalue mean? It is that this factor can explain what is equivalent to 5.717 of the 15 variables included in the analysis. So it is 5.7 of the 15 variable included in the analysis. If we multiply this by the 6.66, which is 15 equals 100, so 1 equals 6.66. If we multiply this by this, it's going to give us 38.11. Same with this, same with this. If we add this 12.53 to this, it's going to give us this one. If we add this 7.9 to this one, it's going to be 58.57, which is the cumulative representative. This 58.547 is that those 3 factors alone can explain 58.547 of the total values that can be explained by the 15 variables altogether. I hope this is clear now. Now, in the SPSS procedure, I asked you to tick screen plot. So screen plot is just a visualization to help you decide or see how many factors are included. Remember, we fixed the variable, the eigenvalue on 1, and we said told SPSS, instructed SPSS, do not include any variable that with any factor that has eigenvalue less than 1, right? So here is the one. This red line is not on your plots, on your screen plots. It's just I added this one myself here. So you can see that above this one, we have only 3 nodes here, which are, in fact, those are the 3 variables here. So which one? First one was 5.7. Here is 5.7. Second one was almost 2, and third one was close to 1. All right, let's proceed. Now, we go for the component matrix and have a look at the component matrix. Now, the component matrix says that the loading of each variable on the 3 factors. The loading of each variable on the 3 factors. So, meaning, in other words, those variables, which factor they belong to most. Now, you can see that the first factor, this first variable, this one, is loaded on the first factor by -0.392 and is loaded on the second factor by 0.566 and is loaded on the third factor by 0.568. Now, the workload, second one as well, it is loaded on the first, the second, and the third. Here, you have empty. Does this mean that this one does not load on any others? Not necessarily. Now, I'm going to repeat Sarah again. Just a minute. Let me finish this one. Now, we have this empty. Remember, in the procedure, we said that one of the ticks, we told you we are going to put it manually as suppress values less than 0.3. And I told you this 0.3 has a good story. So as you see here, you don't have any value that is less than 0.3. So we instructed SPSS not to include in this matrix any point that is less than 0.3, because 0.3 is the threshold for us to be considered as, above it is to be considered as influential correlation. Now here we have all of them, they are all 0.3, all above 0.3. And we can see that those variables are loaded on 3 factors. But we don't want the variables to be loaded on 3 factors. We want each factor to have its own variables. We want each factor to have its own variables. We don't want to mix. We don't want to have one variable to be with more than one factor. So what to do now? In this regard, we go for something called rotation. And remember, in the procedure, we clicked on rotation and we selected Varimix. And then if you can see, after rotation, here is this table is the previous table. This is called component. So this one was loaded on the 3 factors, Now, and this one was loaded here. This one has loaded in 2 factors. Now you can see that after rotation is a matter of discrimination. SPSS is going to discriminate, make borders. You are not allowed to be there. You have to be here. And this is the best for you to be in this factor. This is what we mean by rotation. I mean literally, and not literally, not statistically, but metaphorically. So you can see that this factor, after rotation, first factor has 10 variables in it. The second factor has 2 variables in it, and the third factor has 3 variables in it. What I want you to do is, I want you to go and read. Can you please read those variables here? Read them. Read those variables here. If you read them thoroughly, you will find them that they all belong to one topic, that is personal coping beliefs. Personal coping beliefs. If you read the variables that are included in the third factor, you will find them, they are about non-university pressure. Read them, you will find them. And if you read the variables that are loaded in the second factor, you will see that they are about academic pressure. Now, this is the marvelous of SPSS and factor analysis. In fact, it's going to divide the questions and put them into groups. And when you read those questions and contemplate on them, you will find that they belong really to a specific group. You have to create a title for that group. SPSS is not going to give you the title. You got my point. So, are we good so far? I'm going to return back to Sayara's question, but so far, are we good? All good. Thank you. Thank you. Okay. Thank you. Thank you. Thank you. Now, great. Now, Sayara, I'm going to go back. Sayara asked me a question that why we include only 3 factors. Because in the SPSS, we instructed SPSS do not include any factor that has an eigenvalue of less than 1. So if you can look at it here, it's greater than 1, so we have 3 factors. Any factor that is less than 1, the area is going to appear as empty here. So it is this area that is included in our has three factors, and that's the idea of why we have three factors. I hope that I answered your question, Sarah. Now, this is factor analysis. This is factor analysis now. Now, I want to get back to you to with your question, guys. By the way, you can see the video. Hello? All right. I want to have a question for you. Now we know that we have 13 questions. We included them, in the questionnaire, we included them in a factor analysis, and the results were 3. Now, we want to use those 3 for our analysis in the future analysis. If we want to do, for example, correlation, we want to do regression, we want to do whatever we want to do. We want to use those 3 instead of using the 15. Factor analysis. So instead of using the 15, we are going to use 3 only. Now, let us go and repeat the procedure and add 1 step on the procedure so that we can have those 3 variables saved for us as new variables. I'm going to share my screen with you so that we work together. Yep. Now you can see the screen. It's analyze. Follow me. Analyze dimension reduction. And then factor. Same as we did last time. We click on it. And once we click on it, everything is saved. We're not going to do anything. It's saved. Our work is saved here. You just want to click on scores here. You can see it. This is scores. Yeah, we want to save scores as variables, and we want it to be as regression. Yes, that's the thing. Save as variables and regression. We click continue, and then we OK. Again, I'm going to repeat it for those who have slow devices. Just a minute. Let me just see. Now, this is how we did it. It's analyze, dimension reduction, and then factor. All we have done is saved here. So we just want to add 1 step. This is called scores. We want to have save as variables and make sure that regression is there. We click continue, and then we click. Now, the good news is when you go to your data file, go for variable view, go to the end, you will see that you have 3 factors saved as new variables. Factor 1, factor 2, and factor 3. Now you know what does factor 1 mean. You know what does factor 2 mean. You know what does factor 3 mean. Factor 1 mean coping ability of students. Factor 2 is academic pressure. Factor 3 is non-academic pressure. You can name them here and change their name. Now this is factor analysis in general. Let me go back to my slides. All right. Now, in each and every workshop or seminar, we do answer 4 questions. What statistical technique we have to use in order to solve a specific problem. Our specific problem is that we want to reduce data and we want to make it condensed. Then it's factor analysis. How to use it? It's a procedure. It's on the slides, and it's now recorded as well online. And how to interpret the results? We already interpreted the results. And then after that, how to report it. That is the standardized reporting. I want you to have a look on it. Just you have 2 minutes to read it, then I will come and talk about it. I'm going to just walk for a minute or 2 minutes. All right. Let's go for, let's go and see. This is a standardized reporting. I have no problem if you copy and paste it in final exam assignments, and even in your life, by the way, you can copy and paste, but you need to amend it according to your results. Now, PCA with subsequent rotation, Varimax, it's our rotation, was conducted. So if you use another type of rotation, and there are too many of them inside the SPSS, you have to mention it. On 15 items, how many variables we included in our analysis? There were 15. Completed by business faculty students concerning selected personnel and study problems. This is something that you need to amend. Many correlations were in X of 3. This is in the correlation. And both came on balance tests, produced criteria that supported the application of the PCA. We cannot proceed with PCA without testing the results in KMO and Bartlett's. It's the assumptions test. And you have a slide on it, you can go on that. Then communities varied from, in fact, should be from 3.53 to 751. You go to the communalities table and you see the highest and the lowest number, then you put them here. Applying Kaiser rule and the Scree test, 3 factors were deemed important. Following rotation, factor 1 was loaded on 10 items. This is factor 1, it has 10 items, and that's reflecting general coping ability. Now, the name of the factor, you know how to name it. Nobody's going to tell you how to name it. And accounted for 36.5%. This is the variance that could be explained by that factor. Exemplified by the highest loading item, and then you have to mention some of the factors included, items included in that factor. Then factor 2 was loaded on 2 items, accounted for 11% of the variance. It was labeled academic workload pressure and was presented by, those are the names of the 2 factors, two items included in that factor. And the third factor accounted for 10.9, the variance of the variance, and was loading on 33 items. So just that it was measuring non-university problems. Then you measure the names of the titles of the variants that were included. Now this is a standardized reporting. I don't think that I need to explain because everything is here. Everything mentioned here should be on the slides before that. To that end, do you have any questions? Questions? I'm gonna pull. I have a poll for you. Do you have questions? More answers. More answers. You can't stay without asking, saying no, yes, no, yes, no, no. I need to have an answer, please. You have a question, write your answer. All right, good. No, 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 no. But you have a poll. Who has a question? The one who said yes. Who is this? Yeah, Joy, please ask your question. How much of the percentage would be deemed to be acceptable? Yeah, no. You can't consider it like this, Joy. You can't consider it as like convex alpha. There is no limit for it. Whatever percentage is there. So yeah, I hope you got it now. Now, no questions? Okay, I want you to go to in-class participation test 8 and take it now, please. Take it now. Wow, that was so fast. Who was the first one? Wow, Sayar was the first one to take it. Yeah, take it. Okay, if you have no questions, I'm going to stop recording now.